This is day 20 of Advent of Code 2023, and this challenge is called Pulse Propagation. With your help, the elves managed to find the right parts and fix all the machines. Now they just need to send the command to boot up the machines and get the sound flowing again. The machines are far apart and wired together with long cables. The cables don't connect to the machines directly, but rather to the communication modules attached to the machines that perform various initialization tasks and also act as communication relays. Modules communicate using pulses. Each pulse is either a high pulse or a low pulse. When a module sends a pulse, it sends that type of pulse to each module in its list of destination modules. There are several different types of modules. Flip-flop modules, prefixed with the divide sign, are either on or off. They are initially off. If a flip-flop module receives a high pulse, it is ignored and nothing happens. However, if a flip-flop module receives a low pulse, it flips between on and off. If it was off, it turns on and sends a high pulse. If it was on, it turns off and sends a low pulse. Conjunction modules, with ampersand, remember the type of the most recent pulse received from each of their connected input modules. They initially default to remembering a low pulse for each input. When a pulse is received, the conjunction module first updates its memory for that input, then if it remembers high pulses for all inputs, it sends a low pulse. Otherwise, it sends a high pulse. There is a single broadcast module, named Broadcaster. When it receives a pulse, it sends the same pulse to all of its destination modules. Here at Desert Machine Headquarters, there is a module with a single button on it called, aptly, the button module. When you push the button, a single low pulse is sent directly to the Broadcaster module. After pushing the button, you must wait until all pulses have been delivered and fully handled before pushing it again. Never push the button if modules are still processing pulses. Pulses are always processed in the order they are sent. So if a pulse is sent to modules A, B, and C, and then module A processes its pulse and sends more pulses, then pulses sent to module B and C would have to be handled first. The module configuration, the puzzle input, lists each module. The name of the module is preceded by a symbol, identifying its type, if any. The name is then followed by an arrow and a list of its destination modules. For example, Broadcaster goes ABC, A goes to B, B goes to C, C goes to inv, and then inv goes to A. In this module configuration, the broadcaster has three destination modules named A, B, C. Each of these modules is a flip-flop module, as indicated by the percentage prefix. A outputs to B, which outputs to C, which outputs to another module inv. Inv is a conjunction module, as indicated by the ampersand prefix, which, because it has only one input, acts like an inverter. It sends the opposite of the pulse it receives, and it outputs to A. By pushing the button once, the following pulses are sent. So button is pressed, so low is sent to Broadcaster. Broadcaster sends low to A, B, C. Then A sends high to B, B is high to C, and then C is high to inv. Inv is low to A, and then A is low to B, B is low to C, C is low to inv, inv is high to A. After the sequence, the flip-flop modules all end up off, so pushing the button again repeats the same sequence. Here's a more interesting example. So Broadcaster to A, ampersand A to inv con, inv to B, B to con, and then con to output. This module configuration includes the broadcaster, two flip-flops named A and B, a single input conjunction named inv, and a multiple input conjunction module con, and an untyped module named output for testing purposes. The multi-input conjunction module con watches the two flip-flop modules, and if they're both on, sends a low pulse to the output module. Here's what happens if you push the button once. So low to broadcaster low to A is high to inv, high to conv, then inv is low to B, con is high to output, B is high con is low output. Both flip-flops turn on and a low pulse is sent to output. However, now that both flip-flops are on and con remembers a high pulse from each of its two inputs, pushing the button a second time does something different. So broadcaster low to there, low A's low to inv, A's low to con, inv is high to B, con is high output. So flip-flop A turns off. Now con remembers a low pulse from module A, so it sends only a high pulse to output. So if you push it for a third time, it's going to flip-flop again, so high sends high, and these are low, and then high. This time flip-flop A turns on, then flip-flop B turns off. However, before B can turn off, the pulse sent to con is handled first, so it briefly remembers all high pulses for its inputs, and sends a low pulse to output. After that, flip-flop B turns off, which causes con to update its state, and send a high pulse to output. Finally, with A on and B off, push the button a fourth time. So low is flip-flop to low, so low, inv high, con high. This completes completes the cycle, A turns off, causing Con to remember only low pulses, and restoring all modules to their original states. To get the cables warmed up, the elves have pushed the button 1000 times. How many pulses get sent as a result, including the pulses sent by the button itself? In the first example, the same thing happens every time. The button is pushed 8 low pulses, 4 high pulses sent, so after pushing the button 1000 times, 8000 low pulses and 4000 high pulses sent, multiplying together to give that number. In the second example, after pushing the button 1000 times, 4250 low pulses, 2750 high, multiplying to that. Consult your module configuration. Determine the number of low pulses and high pulses that would be sent after pushing the button 1000 times, waiting for all pulses to be fully handled after each push of the button. What do you get if you multiply the total number of low pulses sent by the total number of high pulses? Okay, so that was a long read to do. Sounds like an interesting challenge. Not 100% sure how to approach it. Okay, so that's what the input looks like. So you got broadcaster. It first sends to all these and then passes all those. So let's grab this, and what we need to do so going through the lines, we're grabbing this. So there are three, what do we need? Actually, let's take another look at this input. Are there any that have nothing? No, it's only broadcaster. Okay, so there are 3 main components. There's the location, the type, and then where it sends it to, but broadcaster doesn't have that. And input, this will be, what are they calling these? Okay, modules. So we'll do modules and dictionary. So for liner here, we'll first line equals fstrip. Then we will do module and then destination equals line dot split. And this will split on this. Print both of them just so we can verify that everything's working. That's working as expected. So now we need to do if module equals if module doesn't equal broadcaster, just verify that this also works, that we've got the correct spelling and that all the white space is gone. Good. Then type equal, actually do m type equals module 0, and then module will equal module 1 onwards. So now let's do that. Okay, we'll put that here. Good, that is working. And we'll actually initialize it m type equals none. And with that, we will now do modules module. This will equal we'll do a tuple, so m type and then destination. So let's print modules. Yep, that is working. Okay, I think that's all that needs to be done for the input. Okay, so how are we going to be tracking this? Okay, so the thing we're recording is low pulses and then high pulses. So we'll start off low equals 0, high equals 0. Okay, we also need the inverse. So there was, which one was it? It was the ampersand. So they remember the type of the most recent pulse. So they need to know which ones are sending to it. So we will record, this will be input map, this will be a dictionary, and for module for module type destination m type in modules dot items. Then this will be for D in destination input map D equals input map dot get D plus module. So when that's done, let's print input map. So if is this correct? Okay, I've definitely done something wrong there. For D, okay, let's print out m type destination. Did I do something wrong? Oh, come on. That looks I forgot to do type mod destination dot split on this. Is that what I wanted? Okay, that looks correct now. Although I don't know if this is right though. Oh yeah. the only input A is broadcaster. Only A goes to inv. Okay, so this one, so it's all singular. Okay, so we should probably choose the other example then. Oh, wait, was this the example that we should want? Okay, just notice there's space here. So we'll do comma space. There we go. Okay, now both of these go to that. Okay, so we've now got that part of it. Okay, so what do these actually do again? I need to... So remembers the type of the most recent pulse. So then we'll also do memory equals dictionary. So remembers the most recent pulse received. So we'll do... What do they start off as? So it starts off as default. So we'll do if m type equals percent, elif m type equals ampersand, and was it percent? Okay, okay, right, the flips one, and then this one remembers. So percent will do module equals, so we'll do false for low and then true for high. And for ampersand, we need to, what do we need to do? We need to keep track of all the previous ones. Okay, I actually have to do this loop afterwards, because, so now that I've got the input map, now I can actually go through this. So if it's ampersand, inputs, actually I don't need to do that, it'll be, what will we do? We'll keep a dictionary of all the ones that can send into it, and we'll make those false. So that'll be memory module equals for I in input map module, then it'll be I false. Okay, let's print memory, see what that does. Okay, yep, that looks correct. So it would be, okay, how does this one work? Remembers the type of the most recent pulse from each when the conjunction model first updates the memory. If it remembers high on all of them, it sends low. So it'll just be, if any of these are false, then it would be high, otherwise low. Okay. And what is it that we're actually doing? So we've got that set up, now we need to actually run it. So we are running this 1,000 times. So do we need to cache it at all? We'll just leave it as it is, and we'll just brute force it to begin with. We could do if, like, as we continue to iterate, if all of these like false, then just go forward in time based on the number of iterations it has been. But we'll do for in range 1000. Okay, what do we want to do? So this needs, what does this need to be? Let's take a look at this. So broadcaster A goes A, then this one goes inv, goes con, then inv goes low, con high. Okay, so it goes in order, so button press low to broadcaster, then broadcaster to low, then broadcaster to A. Because A sends to 2, it sends to both of them, but then it goes to where inv was, but then the next one I sent to was con, so it does that. B. Okay, so we'll do Q equals list like this. So it starts off with broadcaster. We'll just basically do what we've got storing at the moment. So broadcaster, it doesn't have a type, and it's sending a low, so it's false. And then we need to do while Q. So while there's still stuff in here running, we'll do module m type is high equals, actually no, we can do for this in Q. I was thinking we're going to have to like pop it and stuff, but what's going to happen, okay, we'll probably create a new Q, which as we go through this we'll add to that, then when we're at the very bottom we'll replace this with new Q. So new Q equals list, and while we're at it, because I mean the main thing we're doing is the high and low, if is high, high plus equals 1, else low plus equals 1. So doing that. So the next thing we need to do is actually processing the signal pulse that is being sent. So broadcaster is sending to A. Or are we, would it be looking at this? Okay, right, this is the pulse that's being sent to it, the signal. Okay. Actually, if it's output, then we don't need to do anything. So, let me just print modules again. Just double check. Okay. Okay, so output, it doesn't have a key here, so what we do is if module not in, what did I call it? Modules continue. So then it would get, so once it gets the output, it will just continue, which would then carry on like that. Yep. Okay, so now it's actually the part of processing how it works. So, broadcaster, we need to, wait, I realized a mistake in this. For some reason I was thinking this is going to be the type, but really, why did I think this was going to be type? I mean, we don't need to send the type because we already have this. We can just retrieve its type. So we'll change this round. So this is source. Source module is high, and then with this we do m type, and what's the other one? M type. Destinations equals modules module. I just realized it was still running with this loop. Well, let's print m type destination just to make sure this is working. None output. Okay, well that should have been output. Broadcaster output. Print modules. Oh, wait, what am I doing? Print modules. What? Get rid of that. Where did... So we got module, which is broadcaster, and we're putting them to modules, which then gives us... okay, destinations. Okay, there we go. Good, there we go. So we got that now. Okay, so we got the type of the current module, and the destinations that we'll be sending it to. And the type, basically, let's do if m type is none. We're basically just passing on the signal. So for d in destinations, we're doing new q.append, and this is module. So the source is now module, the destination is now d, or the current one, module, and then we are passing is high. So that's what you do if it's none. So now elif m type is a percentage, and we'll just do elif m type is ampersand. So what is percentage again? Okay, percentage is flip-flop, either on, off. They are initially off. Flip-flop model receives a high pulse, is ignored. Okay, so if it's percentage, we'll do current state equals memory module. And what do we want to do for this? If is high, if not is high, it flips it. So memory module equals not current state. Oh, not. So if it's high, it does that. And wait, that is all it does, right? Oh, it is ignored and nothing happens. Wait, is that right? So what in this one, this example, am I getting them mixed up? So that's a flip-flop. They're off. If a flip module receives a high pulse, it is ignored. Okay, so this is low. Okay, so no matter what, it's always sending low to these. But this one, which one was it? So sent low to B, then it worked, but then it's now flipped, so but it's now getting high sent to it, so nothing happens. Okay, so what I'm looking for, if is high, continue, so nothing happens at all. But now, if it's not high, then we do the normal stuff for it. I guess also grab this, put it here, because it's not used there. So we've now got this. We've changed the memory of it, and what do we actually pass? It flips. If it was off, it turns on and sends a high pulse. If it was on, it turns off and sends a low pulse. Okay, so we now do grab this. Oh, we also need to do this, but we'll do not current state. And now it's for, oh, we already did that. So now for this one. So ampersand Where are you at? Remembers the type of the most recent pulse received. So they initially default to remembering a low pulse, a pulse received. Conjunction model first updates its memory for that input. Okay, when a pulse is received, it updates it. So if it's ampersand, it would be memory module source equals is high. And then what we do, if any, we'll do for signal in this, if not signal. So for signal on this, if it's not signal, which means it's low, then send signal equals false. I guess we can actually just do this. And then it's basically just this again, and now using send signal. So I guess now we're looking at this. We need to do q equal, so that's down in this section. Actually, where does this go? Oh, this stuff somehow got outside of the for loop. So there we go. And then q equals new q. And that's the correct one. Yep, so that's outside. And then what we need to do, well, there's nothing left in the queue. Actually, there's nothing that needs to be done. It's when we're outside of this loop. That's when we start doing this, and it'll be return low times high. So let's run that and see what it does. What is this? Line 53. Oh, yeah. Don't know why I did is. Okay, that doesn't seem to have changed anything. What's expected number? Okay, when we hit this, so print underscore low high. So I got to the end and forgot. Okay, well that doesn't seem. Well, I mean, it isn't right. But okay, we're gonna try. We're gonna do print q, and then when we jump out of that while loop, we're gonna exit, so we can see if the flow is working correctly. So that does all correct. Let's print this here as well. 0 to 4. So low. A to inv. So the button to broadcaster is low. The broadcaster to A is low. The A to inv is high. So A is of type percentage. Let's print current state. So false. That is correct, isn't it? Wait. Or does it flip afterwards? No, I don't think so. It's complete cycle. A turns off, causing column to remember only low pulses. This time flip flop. Right, okay, let's go back. So broadcaster, flip flops, AB. So flip A is off. And then B doesn't even run at all. So A to inv. Oh, I know, that is correct. It does send like that. But what is inv is sending high. So, and inv is ampersand. Okay, let's take a look at this. I did not send signal. It should be just send signal. There we go. So false, false, true, true, false, false, true, false. Low, low, high, high, low, high, high, low. Get rid of that print. So low, low, high, high, low, low, high, low. So con to output was not high. Okay, so that's still not correct. So we'll do print memory module in here. So both of these are true. Then what is signal? False. Okay, maybe I miss. So con high output. Okay, what is con? Con is ampersand. And just to verify ampersand. So when a pulse is received, then if the type of most recent pulse received from each of the connected input, they initially default to remembering a low pulse. So when a pulse is received, the conjunction module first updates memory that input. Then if it remembers high pulses for all inputs, it sends low. Okay, it should be wait. Am I confusing myself here? Con. Should said high there. Let's get rid of these. So con sent low. Are these in the correct order? So none, broadcast, A inv, A con. So A to inv was true, A to con was true, inv to B was low, con to output was low. So that's the issue here. So let's print module and that. Ooh, sort. Wait, no, that's right. So so both cons to outputs is false, but it should be. Okay, we also need this. So that's correct, false. This should be true. Okay, better yet, what does this return? Okay, returns empty. Let's remove the if statement and see what it does. Dot. This should be values. In dot values. Okay, that looks better. So low, low, high, high, low. So why is it still doing false? Okay, put dot values everywhere. And we'll put the if not signal back in here. Okay, we're gonna have to do something dumb where it's. So I think what it's doing is. Yep, so because I'm putting false into the list, it's going if any, as in if anything in the list is true. So I need to do not signal. For low, low, high, high, low, high, high. There we go. Okay, we finally got that. So let's get rid of the prints and see what it gives us. Is that actually, that might be correct. I thought that was way too high for a second, but that does look like it might be the right answer. Yes, it is. So we'll now grab this input, put it here, and we will run it. 856482136. And there we go. Part 1 is finally done. Now, on to part 2. Okay, so we've got a single RX in here. Do we have THs anywhere? Okay, we got multiple, and I assume they'll go all the way up. So, do we just do, I don't know, if module equals RX and not is high, return this? Is that what it's wanting? Oh wait, I need to move this into part 2. So get rid of that and paste this into part 2. So if module equals RX and not is high, return that. Is that what it wants? How about do that? Okay, so this is going to be, so this, they were able to set it up so it would take a very long time to get to RX is not low past the RX. This will not work, but I'm just going to do it anyway. Okay, so that's definitely not going to work, so let's revert it back. And I'm not really sure how to actually go about solving this. Okay, let's go back to this. So how do we make sure that a low is sent? So if a low is sent, it flips it. Okay. And then with this one, it sends low when all its inputs are high. Okay, well, to be honest, I don't know if I can actually solve this. Like, I'm kind of lost as to where to even start. So it's going to have to do with the patterns in it, I'm assuming. So you go through it like once, or X amount of times, and then you start at the original again. That's just the same thing again. No, actually, okay, no, I don't really have a clue how to do part 2. I think I'm going to have to just find a solution that someone's already done and then just implement it here, because I got no clue how to do it. So I found a solution for how to do this, and I guess I'm just going to copy it, and I guess I'm going to try understand with you guys what is going on, because I'm not really sure how to do this. It was obviously brute forcing it isn't going to work. I've got a feeling it's got to do with like certain patterns within the signals, and you probably have to go RX upwards or something, I'm not sure. So, well, I'm just going to copy this line by line and implement it and using the stuff that we've got. So I guess let's get started on that. So it's starting off with getting the input module for, do I have input map here? Okay, I need to grab this stuff here. So now I've got input map. So module equals input map, and then we're doing RX, so grabbing the input for that, and then 0, because there's only one thing that passes to RX right here. So grabbing this one, we are then grabbing the sources for it, so this will be input map as well, module, and sources, so of that. And what they've done is created a dictionary called low counts, and then they've got cycle equals 0. And they're doing while length of low counts is less than length of sources. So assume low counts. So this is gonna interesting that it contains a dictionary, or is this meant to be a set? Okay, no, that is a dictionary. It's a dictionary that's holding the cycles. Okay, so while it's lower than that, cycle plus equals 1. Okay, interesting that it goes cycle plus equals 1. I was thinking it would be like kind of segmented areas, but that's fine. So Q equals basically same thing as before, none. We'll grab the broadcaster one here. So we've got our Q, and then while Q again, new Q equals just list. Then we're doing for source module is high in Q if module in sources, so that one, if not is high, if module not in low counts, then low counts module equals cycle. Okay, so we're doing cycles for the last of the sources here. So that's ampersand. Okay, so we want to be ampersand, so it's ampersand, and if one of them is, wait, how does ampersand work again? So if it's default low, no pulse received, if it remembers, interesting. Oh, right, this one. So this one, it will be passing low to here. Wait, I don't know. Thought I understood for a second there, but I don't. Okay, we'll just continue copying on and hopefully we can figure it out. So for source, we've got cycle. So if it's not high, cycle. And then we'll carry on here. If node equals Rx and not is high, and then if module equals Rx and not is high, apparently Rx count plus equals 1. Where does Rx count come from? There. Okay, I'm not sure if that's needed. Okay, so the next thing we do, we've got info equals modules dot get module. If info is none, continue. And then they're doing m type destinations equals info. Then if m type equals percentage, and if is high, continue. Otherwise, state equals memory node. Actually, don't need to do that. Then memory module equals, actually state equals module. Then memory module equals not state. Then for D in destinations, new q dot append, and this will be module destination not state. Okay, from looks of things, they're basically just copying the rest of this, so I'll just copy that and put that here. And then they also do the q equals new q here, set in line. Yes, it is. Okay, yeah. So once they're outside of the while loop, the main one, they are doing math. Do I need to import that? Yep. Math.lcm low counts dot values. That's what they're doing. So I had a feeling it was going to be similar to that previous challenge where it was the patterns. Or am I mixing two together? Yeah, I'm mixing two together. There was one which was the patterns, which you're going through, and then you have to do the modulus math. Then there's another one which was LCM. I can't remember what that one was. But anyway, it ends up as that. So there'll be a certain amount of cycles where so low counts, if module non low counts, if not is high, if module. So what if module in sources? So it's iterating through it all. If module in sources, what is sources? Sources input to module. So that's everything that passes to there. Okay, so it's going through. Once it reaches a point where one of the last modules returns low, it then adds that that cycle count to the dictionary, and then it's going to basically store for each of them. And this while loop basically is just checking to see, it's going to iterate until all of them are in there, all of the counts for those last few modules are in there. And then when that's out, with those cycle counts, we're getting the lowest common multiplier, whatever it's of CM, and then returns that. So let's go and run it. Okay, got line 102. There we go. And run that. Whew. Yeah, no wonder brute force wasn't working. Large number. So before I paste that in, let's do a line by line. So we're trying to get to Rx, so we're looking at the inputs that are going to it. We know there's only one going to Rx, and what is it that we want? Single low pulse sent to Rx. So now let's look at TH. TH has a bunch of things being sent to it, but TH is an ampersand one. Although this is the thing that I don't understand. Remember, high pulses for inputs, it sends a low pulse. So we want all the previous ones to be high, but we are doing it so if not high. So maybe I should change it to high. We'll try this number and then we'll make it higher. But anyway, let's assume that this works. So got that module, now we're getting all the inputs for that. So the sources into the module, which then goes to Rx. Dictionary, which is going to be used for the sources, where we're storing the amount of cycles required to make that one low. Then just cycle mount. So while we haven't found all the cycles yet, we're going to do everything as normal. Go through the queue and scroll down. Based on its type, you're going to be changing the signal that's sending. But the main part is here. So if module is in sources, as in we've reached the end of the cycle where we're at the last modules, which are sent to Rx, or the one before Rx, if it's not high, and if it's not in load counts, then we get the cycle number for that. So that is the least amount of cycles required to get to that number being low. And it's assumed that there is a cycle to how this works. So we get to there, and then that is the main thing for it. So we've now got this number, let's paste it into here, submit. Okay, that was the correct way. Although I'm still not sure. If not is high, then we do cycle. Because, actually let's go back to it. What is the fewest number of button presses required to deliver a single low pulse to module named Rx? Because shouldn't it be all high? Actually, let's read over this. So for source, if module in sources, so module is, yeah, so module sources is this. Wait. Okay, so I think we're looking at the one above it actually. So like this one. Wait, that doesn't make sense, does it? Yes, it does. So if a low is being sent into there, okay, so it must be kind of predetermined that all of these are going to be ampersand. So for low, so we've got THZL, say this one. So if a low is passed into this, a high is going to be passed into this. So then if all of them are high, then okay, I get that one now. Okay, well, I wouldn't have been able to figure that out by myself, so I'm happy I looked up the answer before wasting hours trying to figure it out. But hopefully the rest of the challenges I don't have to look up the answer, but yeah. Anyway, that was day 20 of Advent of Code 2023. If you like this video, make sure to like and subscribe so you can watch me complete part 1 and maybe have to cheat for part 2.